Hey guys, this is Mr. Grice for Algebra 1, Chapter 11.2 Notes. Today we're talking about simplifying radical expressions that contains variables. Our learning target today is to be able to simplify, multiply, and divide monomial radicals with variables. So let's go ahead and get started. Go ahead and write the definition of simplifying radicals that contain variables. Pretty much what it means is to simplify or break down each variable separately. You divide each exponent by 2 in groups of 2, and the remainder stays inside the radical. You might be like, whoa, Mr. Grice, that sounds like Chinese. That's okay. Let's go through a couple examples and you'll start to get the hang of it. All right, so remember that that symbol is called a square root, okay? That's why we're looking for groups of 2, all right? So it's by itself, so we don't have to worry about anything. Now what I'm going to do is I'm going to write this out the long way. So it's m times m times m times m times m times m. I'm looking for groups of 2. So there's a group, there's a group, and there's a group. How many groups do I have? Well, I've got 3. So our answer would be m to the 3rd. Okay? What we pretty much did is we took that exponent 6, divided by 2, and it equals 3. And that's how we get our answer. Okay? Now, when we've got 2 variables like that, we're going to split it up separately. Okay? Now, if you want to write it out, you can do that. I'm only going to do this for the first couple, otherwise my hand would get tired. 3, 4, 5, 6, 7, 8, 9, 10. Okay? We have one group, so that's where we get x. And then for y, we've got 1, 2, 3, 4, 5. 5 groups. Okay, but what happens if we don't have any? Okay. There's no groups. Okay. This first one, there's nothing. Okay. So I can't reduce it. It stays like that. Okay. But when we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Woo, your hand would get awfully tired doing this every single time. There's 1, 2, 3, 4, 5, 6, but then we've got that remainder. Okay, so we have y to the 6, but then our remainders stay underneath the square root. Okay, now the fast way of doing that is just dividing, because if you divide, say you got 13, you divide it by 2, we've got 6, and that's where the 6 comes from, and that 0.5 means that the other y stays inside. Okay, so let's go ahead and break down number 4. We got a to the 12th, b to the 23, and c to the 14. I want to divide each one of those by 2. Okay, and when we divide all of that out, we get a to the 6th. Oh, we're gonna, sorry. So a to the 6th, we get b to the 11 with the remainder, and then c to the 7th. And the last thing we're going to do is we're going to make that look all nice and pretty. So a6, b11, c7 with the b underneath the square root. Okay? So that makes sense? it's going to take a couple of these just to get used to. Okay? And now, when we're doing simplifying radicals that contain numbers and variables, you simplify each number and variable separately. Variables in groups of 2, just like before, and then combine the coefficients or the roots at the end. Now, whenever we're doing the numbers, you need to make sure that you write down all of the perfect squares on the side, because this is how we should be splitting everything up. Okay? So when we break down 27, that breaks down to 9 and 3, and then m to the 8th. The square root of 9 is 3, root 3, and the square root of m to the 8th, 8 divided by 2 is 4. So when we rewrite that, the 3 and 4 come together, and root 3 goes to the end. Okay? So break down 243. So divided by 144, nope. Divided by 121, nope. Nope. Divided by 100, nope. 243 divided by 81, 3. Okay, so 81 and 3, x20, y5. We get 9, root 3, 20 divided by 2 is 10, and then 5 divided by 2 is 2 with a remainder. So then to make it look pretty, we're writing all of the coefficients out front, and then we write our remainder inside. Okay, so if it stays underneath the square root, we just combine them together. If it wasn't in the square root, we combine those together. Okay? Alright, let's look at 6. Okay, that negative 3 stays out front. 100, a to the 12th, b to the 13th. Okay, the square root of 100, that's a perfect square. That breaks down to 10. A to the 12th, the square root of a to the 12th is a to the 6th, because we just divided it. And then 13 divided by 2 is 6 with a remainder. Okay? So the only thing we have to do is to multiply those numbers, and then to write everything out nice and pretty. Okay, 7. What breaks down 80? And do not say 40 and 2, because 40 is not on our list, guys. Okay, we have to do it in perfect squares. Okay, when I did this, we got 16 and 5. A to the 6th, b to the 3rd. The square root of 16 is 4. Root 5, a to the 6th breaks down to a to the 3rd. And the square root of b to the 3rd is b root b. Okay, outside with outside, inside with inside. Okay, why don't you try number 8, and let's see how you do, guys. Go ahead and pause the video, please. Okay, that's what you should have gotten when you've broken everything down. Square root of 9 is 3. Root 5. Root x, that stays in there, and y to the 4th. 6y to the 4th with the square root of 5x. Okay. So 162, what breaks down in 162, and that's 81 times 2. Remember, everything gets its own little square root. Square root of 81 is 9. Square root 2. 7 divided by 2. Remember, if you need to use this 7 divided by 2, it's 3 with a remainder. So m3 with a remainder of m. And 9 divided by 2, it's 4. So n4 with a remainder, okay? It's good to stay organized so you can see all the different pieces that you've got, okay? 9m cubed n to the 4th 2mn, okay? Just remember, outside with outside, inside with inside, okay? Last couple ones. Now, when it looks like this, like a fraction, you still break it up. Everything individually. The square root of 9 is 3, the square root of 4 is 2, and the square root of x to the 4th, it's 2. Okay, square root of 16, square root of x, which gives you 4 root x. And remember, you can't have the square root on the bottom, so you multiply the top and the bottom. The bottoms do not cancel, okay? It just stays x, because remember, root 2 times root 2 is 2. Root 10 times root 10, that's 10. Okay, so root x times root x is just going to be x. It does not cancel. Alright, and last one, to get rid of the roots, you multiply by 5y, and you get 15, 5y over 5y, and we're not done because you can reduce, okay? Always reduce. And that's your final answer, okay? That's going to be it for Algebra 1, Chapter 11.2 notes. If you have any questions, please come see Ms. Carranza or myself. Otherwise, thanks for watching.